Hello. So today we will be solving this problem. Design a number container system. So the problem says design a number container system that can do the following: insert or replace a number at a given index in the system. Okay. Return the smallest index of the given number in the system. So we have to implement this class number containers, and this is the constructor of this class, and we have a change function. So change function takes a index and a number, so it fills the container at this index with a number, this number. If there already a number at that index, we will replace it. Okay. And we have a operation find, which takes a number as the input and returns the smallest index for a given number, or minus 1 if there is no index that is filled by the number in the number system. Okay. So basically this particular function change will insert or replace a number at a given index in the system. Okay. So let's say we have a array, means we have containers. Let's say indexes are 0, 1, 2, 3, 4, and 5. Okay. So we have this empty container, and we need to fill these particular containers with a given number. Means we will be given with the index. Suppose we are given with the index 1, and in index 1 we need to put a number 2. We can put a number 2. Similarly, we are given a index 2, and we need to put a number 3. Okay. So we can put a number 3 here, and we can also have a replace operation. Suppose we are again given index 1, and we want to put a number 3. So we need to replace the index 1's value with the 3. Okay. Then we have a find function. So what find function will do, it will give us the smallest index for the given number in the system. Okay. So we will be given with a number, and we will check if that number is present in our containers. So if it is not present in our container, in that case we can't return its index, so we need to return -1. Otherwise, if it's present, so we need to check the minimum index at which it is present. Suppose we have a call for find 3, means we need to find the index of the number 3. So in our container, the number 3 is present at two positions, which are 1 and 2. So we need to return the position 1. Means we need to find the smallest index of that number. Okay. So our container does not have a size which is limited. Means indexes can be anything in our container. Means we can have 10 raised to the power 9 values of the indexes, and at most 10 in 10 raised to the 5 calls will be made in total for change and find. So basically at max, if all the calls are for change, at max we can have 10 raised to the power different indexes, so which can be within this range. So we cannot store our basically the values at the indexes in an array. We can use a hash map. Means uh, in hash map we can keep track of the basically the index. Suppose we make a hash map. uh, let's say we have a hash map of integer, and we can store in that hash map index to the number mapping. So we can store that means on this particular key, means for this particular index we have this value present in our hash map. so that will help us. Okay, and we also need to return the smallest index for a given number in the number system. Means a number can be present at multiple, let's say multiple indexes. Here 3 is present at index 1 and index 2, and we need to return the smallest index. So what we can do is to find the smallest index, what we can do, we can have a number, and against that number we can have our priority queue. Means for every number we can store the priority queue, its priority queue, and uh, priority queue will have at the top the minimum number. Suppose number 3 is present at this position, at these positions 1, 2 and 3. Okay, and now we are asked, we need to return the minimum index for the 3. So we can pop our priority queue, and we can give the 1 as the answer. Okay, and after doing this, what we can say is, we can replace the number 2. Suppose we have a change call and we will replace the number 3, means the number at the second position, with a, let's say, value 2. Okay, so now our 2 index will have a value of 2. Means what we can say, our the number 2, our number 2 is present at second position. So the problem here is, in our priority queue, our 3 is still have index 2, means 3 is still present at 2. So what we can do is, suppose before putting a number, means we will check if already a number is present at this position, means 3 was present at this position. So what we can do is, if we remove the 2 from the priority queue, means we can remove, suppose we have priority queue PQ and we call the remove operation, that remove the index 2 from the number 3, because now this number is assigned to a, this index is assigned to a, means in this container now we are putting the number 2. So we will remove the 2 from the list of indexes of the number 3. But this operation will take the big of n time. So basically this will give us the TLE. So to encounter, means to solve this problem, we can have two ways, two approaches we can use, I think. Approaches. So first one is very simple. What we can do is, in Java we can use a tree set. Means instead of using priority queue to store these numbers, we can store a tree set. So what tree set do is, stores elements in sorted order, and what are its properties. So it can basically, we can retrieve minimum element in big of one time, because it will be present at the very first index in the tree set. And second one is deletion. So deletion in the tree set takes big of log n time. So this will work, means we can use a tree set. So in my previous submission, which was in 22, I have used the same approach, which is I have made a map to store the index to a number mapping. Means against an index we can store a number, and then I have made another map which is map and its indexes in the tree set. Okay, so we can use this approach also. So instead of using tree set, we can also do it using the priority queue also. So how we can use priority queue? So let's say we have this priority queue. So we have the top of the priority queue, means we are asked to find the, let's say number, this index 1 is also assigned to the number 2. So now the answer for the 3 will be 3 index, because at 1 index 2 is present, at 2 index 2 is present, so 3 is only present at this index. So we need to return the minimum index for 3, which is one and only index 3. So what we can do is, we can check if the peak of the priority queue, means the minimum index which is present on the priority queue. So we can check, so we will find the peak, means the min index, and then we can check for the, let's say in our index to number map, that we will give it a index, this index. So it will give us the value at that this index. So value at this index will be 2. So we check this 2 value, means at this particular index the value is present at 2, but it is present in the priority queue of the 1, 3. So 1 is present in the priority queue of the 3, but the number at the 1 is not 3, it is 2. So that means somewhere this index got updated. So we will not consider this index, and we will pop this index. Similarly at 2, we will check what value is present at 2 index in our this map. So at this index the value is present is 2, which is not equal to the number which we are required to find the index for. So we will pop this value. Now we have index 3, so we will check the value at index 3. So the value at index 3 is 3. So yeah, so now we can say that the this value will be answer, that the minimum index for 3 will be 3. So that's how we can use the priority queue. So we have this map, we need another map where we need a priority queue. How to initialize the priority queue, let's see. Okay, so we have initialized tree set like this. Okay, so we need a priority queue of integer. So we will call this map as the number to indexes map. And we will whenever our this class object gets called, we will initialize these two maps. Now what we can do is, we have given this operation, so simply we will take this map and we will put at this index this number. So this operation will itself do the replacement operation. If some value is present at this index, it will automatically replace that value at the number. If it's not present, then it will put that value against that number. Okay, so we have initialized this map. Okay, now we need to find the find operation. Okay, also what we need to do, we need to, for this number we need to put against this number, we need to put the index on it is present in this priority queue. So what we can do is, we can number to indexes dot compute if absent at this particular number. We will see if a priority queue is initialized or not. If it's not initialized, we will put a priority queue, new priority queue, and in that priority queue, if it's already present, it will return as the already present priority queue. Otherwise, if it's absent, it will put a new priority queue, and in that priority queue we will add this index. So we have placed the index against this number, that this number is present on this index. Now we have this number, so what we will do, we will find the priority queue store against this number. So priority queue of integer, let's call this indexes. So this priority queue will contain indexes at which this number may be present if it's not modified. So what we can do, we can find, can call get or default. We can find priority queue at this particular number. If no priority queue is present, means we are only putting a priority queue if a call is made for that number. Suppose we directly make this call, and in that case there will be no priority queue present, so we will return an empty priority queue in that case. New priority queue. Okay, so until our priority queue is not empty, so while size of our these indexes is greater than 0, uh, we will pop out the indexes. So the current index, means the current smallest index will be indexes dot poll, and we will see if the number present at this index, index to in our index to number map dot get suppose okay, so that will be present. So we will find the number at that index. If that number is equal to our current number, that means the number is still present at that index and the current index is the minimum index, so we can return this index. Otherwise we will go for the next index and check if that is present. If we don't find that index, we can return -1 at the end. Okay, so I think that is the implementation of this question. So let's look for any syntax errors. Let's read our code. So we are making a hash map index to number. We have initialized this map. Okay, we are making a hash map of priority queue and we are initializing that map. Okay, now we are calling the change operation. We are putting in our index to number map the index and the number value. Okay, and also to number to indexes map we are compute if absent. We are checking if priority queue at that number is present. If it's not present, we are putting a new priority queue and adding the index to that priority queue. Otherwise we are calling the find function number. And priority queue of integer indexes. Okay, so number to indexes, we have found the priority queue for this number. If it's not present, we will find empty priority queue. Okay, if its size greater than 0, we will find the minimum, means we are polling this priority queue. And if index to number dot get index equals to that number, okay, we are returning the index. We are returning the index. Okay, otherwise we are returning -1. I think it looks okay. Let's see. Okay, so case 1 is running. So can we try to submit this? Okay, we are getting a wrong answer. Let's see. Let's debug. So we are getting wrong answer till here. Okay, so what we can do, we can use this test case. Hmm, wrong answer. We have this test case. Okay, so we are getting 0 1 2 3 4. 0 1 2 3 4. Okay, 0 1 2 3 4. Okay, so we are getting wrong answer for this test case. Let's run this test case. So this test case is giving us the wrong answer. Okay, so let's see. What we have done is we have called the change operation, means at 25 index we are putting value 50. So what we have done is after calling this, what we are doing, we are putting this value in map. Against 25 we are putting 50, and against 50 we are putting the index 25. Okay, then what we are doing, against 56, the index 56, we are putting the value 31, and for 31 we are putting index 56. Okay, now we are finding the value. Okay, for the 50. Okay, So that's why we are getting wrong answer, because what we are doing is we are polling, we need to find the peak first, and if that peak is not present, in that case we need to poll it. Means we are polling the valid index, so we just need to check the peak, if that index at that peak is a valid index for that number. If it's not valid, in that case we will need to poll that number. So I think that was the issue with our code. So let's submit this. Okay, so this was the solution for this problem. Okay, thank you guys.